Hello, this is 5.4, Solving Trigonometric Equations. Now, you may look at this title, and I'd agree, you've done it before, and you have done it before. The only difference here is it's in radians. So really, if you can solve trigonometric equations with degrees, this really isn't going to be very different, and you almost think of it as revision, which isn't a bad thing. So here we go. First example, solve the equation sine 3 theta equals root 3 divided by 2 or over 2 in the interval of 0 to 2 pi. First, do make sure that your calculator is in radians, and usually that's shown by the top of the screen, that it's in radians. So if I have a look, here's my calculator. And if I look at the top here, it's in degrees. You see it says deg, so that's not what I want. So shift, menu, because that gets me the setup function. And if I scroll down to here where it's the angle, I can swap to radians and I'm all good to go. So if sine 3 theta equals root 3 over 2, then I know that 3 theta is equal to sine to the minus 1 of root 3 over 2. So that's how I'm going to work out my angles. And so 3 theta would be, and typing that into my calculator so that I can calculate the angle. The answer comes out as pi over 3. Now at this point here, I'm going to draw my sine graph. Now it's 0 to 2 pi, but I'm going to divide all my answers by 3, which means actually I'm going to go from 0 to 6 pi. So let's go. That's 0 to 2 pi, and then again. And I'm going to run out of space. So that needs to carry on. So there's 2 pi. Now that's pi, 4 pi, 6 pi, 5 pi, 8 pi. So that's all my points where it crosses the x-axis. Pi over 3. Now, if you're struggling to imagine that, remember pi is 180. Lots of students go back and convert. So that there is pi over 3. So that also has another one just here. And we need to work out what that one there is. Well, if from here to here, if that distance there is pi over 3, then this distance here must equally be pi over 3. So that was pi, and I've got to take pi over 3 off. So that point there would be 2 pi over 3, because it would be a whole pi take away a third. So that would be 2/3 pi. So that's my next one. Because 2 pi over 3 is the same as 2/3 pi. Where's our next one? Well, our next one is there. So that there is 2 pi plus our third again. So that's 2 wholes plus a third. Well, 2 wholes, that would be 6 pi, plus another one is 7 pi. And if you think about it, from here to here, when it's repeating 2 pi later, that's like adding 6 pi over 6. Sorry, what am I saying? 6 pi over 3 on, because 6 pi over 3 is the same as 2 pi. So you can think of that as well. Then it happens again here. So that's 1/3 off of 3 pi. So that's 8 pi over 7. Sorry, over 3. Then here, third onto that one, 13 pi over 3. And this one here, third off of 5. So that'd be 14 pi over 3. And that should be all of them. And then I must work out what theta is. Now, I'm just going to say this again. We work out all the solutions for 3 theta, and then we divide by 3. We don't work out 1, divide by 3, and then work out the rest. If you look in the textbook, I believe, shows you a way of doing this. I think, I'm not sure actually. No, it doesn't. I've just checked. But the way, if you want to divide it by 3 at the end, you'd have to draw the graph of 3 theta out, whereas this is the graph of sine theta. So dividing by 3 now. So, and that is your answer. 4 sine 3 theta equals root 3 over 2. I know I'm repeating myself, but find 3 theta, find all of the angles, then divide by 3. And that's it. So when we're attempting this, the first thing we need to realise is we have cos and we have sine. And when we're solving a trigonometric equation, it's usual that because this is a quadratic, it's already looking like to me, I'm going to want to factorise it. So I want it all really coses or all sines. So the identity which you should know that links them is that. So sine squared theta plus cos squared theta equals 1. And sine squared theta is therefore, if I rearrange it, 1 minus cos squared theta. And 17 cos theta, add 3 lots of 1 minus cos squared theta equals 13. So I then expand this and rearranging. I would just say, if you check the textbook for this question, there is an error in the printing of the initial question, which is then corrected later. The original question has a 2 there. So just to warn you if you do look in the textbook. So here we now have our quadratic, which we need to factorise. Now remember, you can use your calculator to factorise this, which is absolutely fine. Just looking at it quickly myself, I'm going to make that -5, that 2, this cos theta, and that also negative. So I'm going to end up with cos theta equals 2/3 and cos theta equals 5. Now, at this point here, you should realise that this is not a solution. So not a solution because that's not possible. And the examiner does want you to be bold about that. You'll be surprised how many students start doing funny things with that when they get the results out. So they're looking, do you understand immediately that that's not possible, that cos theta only goes between 1 and -1? Do you have that comprehension, or are you going to start getting in a tizzy? Okay, yeah, that's low grade students, but they are testing lower grade students as well. So make sure you're clear, not a solution, finish, and we can't do anything with that. So we're left with cos theta equals 2/3. So we go to our calculator for that and we just type that in so that we can actually get the solution out. And the answer comes out to be 0.84. I'm going to go for a few extra decimal places just to start with. 1, 1. So, and that, remember, we're working in radians, okay? So thinking now about our cos graph. That's 2 pi. This here is pi, and this is 0. So 0.8. Well, here, this is 3.14, because that's what pi is, remember? So half of 3.14 is just over 1.5. So sort of 1.5-ish, 1.6 is here. You've got 0.8. So we're talking about something about there. So the next place it's going to happen is there. And what you've got to look at is that graph symmetry again. So from this maximum down to here is 0.84. So do you notice that's the next maximum down to here? This distance here will equally be 0.8411. So the next one will be at 2 pi, subtract 0.8411. Now there's lots of ways of doing this. And I know that some of you prefer to say, well, I'm going to work out that bit and add it on, and that's fine. Don't think that my method, your method is any better or any worse. It is about how you visualize it, and it's really important that you have a firm understanding of that visualization. Personally, I think this is easier, but if you're not confident, it's not easy for you. So just look for that graph symmetry, that is the same as that bit, or this bit here is the same as that bit there, and you've got to add it on. So my final answers for this question, and I'm going to now write it to 3 significant figures because that's what would be expected. And this one here would be 5.44, having typed it in my calculator. So there we go. That's one where we've actually used trig identities.